In this video, we are going to learn about gravitational force. So gravitational force is a force of attraction due to which every body of the universe attracts every other body of universe. So gravitational force is a force which acts between every two body of universe which have mass. Now Newton's law of gravitation, according to this law, every body of the universe attracts every other body of the universe with a force which is directly proportional to the product of their masses. So suppose there are two bodies with the mass m1 and m2, then the force of gravitation acting between them is directly proportional to the product of their masses, that is m1 dot m2, and inversely proportional to the square of distance between them. So if r is the distance between them, then f is directly proportional to 1 by r square, or inversely proportional to r square. So combining these two, we have f is directly proportional to m1 m2 upon r square, where f is gravitational force acting between two bodies of mass m1 and m2 and distance between them is r. So we have f is directly proportional to m1 m2 upon r square, and we can write it as f is equal to g m1 m2 upon r square, where g is equal to universal gravitational constant. It is called universal constant because its value is constant throughout the universe. That is, its value does not depend on the medium or anything else. So in SI unit, gravitational constant is equal to 6.67 into 10 to power minus 11 Newton meter square per kg square. So the value of G is constant throughout the universe and is equal to 6.67 into 10 to power minus 11 Newton meter square per kg square. Now Earth is a body with say radius r. Radius of Earth is equal to r, which is roughly about 6,400 kilometers, and let's say mass of Earth is equal to m. Then, in accordance with Newton's gravitational law, the Earth will attract every body towards its center. So if a body with mass m is lying near the surface of Earth, then the Earth will pull this body towards its center with a force which is equal to g into mass of Earth into mass of body upon radius of Earth, if the body is lying near to the surface of Earth. Now what is gravity? The gravitational pull by Earth is called gravity. Earth's gravity is Earth's gravitational pull. Now let's study out acceleration due to gravity. It is denoted by g, is acceleration set up in a body which is falling freely under the effect of gravity. Now suppose a body of mass m near the surface of Earth, then force due to gravitational pull of Earth on that body is equal to g mass of Earth into mass of body to radius of Earth square. Then we have gravitational pull of Earth is equal to gm by r square. Now as we know that we have to calculate acceleration due to gravity, that is acceleration set up in a body due to this force. Now we know that force is equal to mass into acceleration, so imply that acceleration is equal to force upon mass. So acceleration due to gravity, which is g, is equal to force is equal to this force upon mass of the body, which is equal to gm by r square. Gm by r square, and its unit is meter per second square. So we have acceleration due to gravity is equal to gm by r square, where g is universal gravitational constant, m is equal to mass of earth, and r is equal to radius of earth. So this is acceleration due to gravity set up in a body which is falling freely under the effect of gravity alone. Now we know that mass is equal to volume into density. So if m is mass of earth and volume is equal to 4 by 3 pi r cube and density is rho, then mass is equal to 4 by 3 pi r cube rho. If we substitute this in acceleration due to gravity, then we have g gm by r square, and m is equal to 4 by 3 pi r cube rho. So g is equal to g 4 by 3 pi r cube rho upon r square. So r cube upon r square is equal to r. So we have 4 by 3 g pi r rho r 4 by 3 pi g r rho. So acceleration due to gravity in terms of density of earth is equal to 4 by 3 pi g r rho, where g is equal to universal gravitational constant, r is equal to radius of earth, and rho is density of earth. Intensity of gravitational force. So intensity of gravitational force at a point in a gravitational field is equal to force experienced at that point by a unit mass body. Force experienced at that point of gravitational field by a unit mass body. Then intensity is equal to force experienced by a unit mass body, that is force upon mass of the body. So force due to earth is equal to g m by r square upon mass of body is equal to gm by r square. So I is equal to gm by r square, and acceleration due to gravity is also gm by r square, and both have same unit, meter per second square. Now intensity is force experienced by a unit mass of body, and g is acceleration due to gravity. But as we know that force is equal to mass into acceleration, if we put m is equal to 1, that is force experienced by unit mass of body, then force is equal to 1 into acceleration, implies that force is equal to acceleration if mass of the body is equal to 1. So that's why here the value of I and g are equal, since g is acceleration due to gravity and I is equal to force experienced by a unit mass of body, and if we put m is equal to 1, then force is equal to acceleration. Now as you can see that g is equal to gm by r square. So acceleration due to gravity is independent of the mass of the body and only depends on the mass of earth, which means that if we drop a paper and a stone, then both will have same acceleration due to gravity implies that both will accelerate at the same rate towards Earth. So if we drop them from same height, they will reach the surface of Earth at the same time. But this does not happen due to air resistance. So if we drop a paper and stone in a vacuum chamber, then both will reach the Earth's surface at the same time.